Hello, Fayatin. Welcome back to our physics class today. Today is our strand 1, lesson 2, heat transfer. We're still on heat transfer. We're going to go deeper into the concept today for our lesson 2. Our keywords for us to focus on today are heat transfer, combustion, temperature, insulator, conductor, heat capacity. Our learning outcomes for us today is to investigate applications of heat transfer and energy changes in real-life situations and recognize the factors that influence the transfer of heat, and also identify what an insulator is and what a conductor is. Remember our prior knowledge from Year 9 Science and also from our previous lesson from Year 10, Lesson 1, what is energy, sources of energy, energy form, unit of measurement of heat, heat transfer method, combustion, and radiation, and even difference between heat and temperature. Our warm-up activity is to answer our challenge question from our lesson 1. Remember the question from lesson 1 at the end? I gave you 3 questions to challenge you to go and think about it and answer it. Now let's have a look at the first question. The first question says, remember our activity 1 from lesson 1, we were trying to melt the ice tube using sunlight, right? Remember that? So the question was, would it make any difference if you had crushed the ice in the bath from that lesson? What difference would that be? Would it make the heat transfer faster? Okay, if you had crushed the ice, would it make any difference? What do you think the answer is? The answer is yes, because if you had crushed the ice tube, it means you are exposing the more surface area of the ice tube to the heat. Okay, when you squash the ice, there is more surface area exposed to the heat, and so the ice melts faster. If you really think about the real life situation of the melting ice in Antarctica, you're all familiar with the Antarctica. You know the huge ice block in the Antarctica is breaking down into smaller chunks, and the more smaller chunks exposed, more surface area exposed to the heat from the sun, the more the Antarctica is melting, and that's why our sea level is rising. So that's an application in real life situation of this concept. Now remember the second question. Second question for our activity from lesson 1. Remember we were trying to spin the paper spiral using the heat from the candle. Now the challenge question for you after that lesson was, would it make any difference if you had used a Bunsen burner or even a study light instead of the candle? What difference would that be? And would it make the spiral spin faster or slower? The answer is yes. If you had used a stronger heat source, the spiral would have spun faster. Why? Because with the hotness or the more heat from a heat source, the higher the heat source and amount of heat, the higher the temperature difference, and also the higher the density. Okay, and that means the transfer of heat will be much faster. Remember the activity 2 from last lesson was convection, right? Hot air rise, cold air go down. So le amount of heat le amount of heat le heat source, the faster this process go, and therefore the spiral was being much faster compared to the candle. Now, our last activity from last lesson was the demonstration of heat conduction using the spoon and the toothpick. The challenge question for you after that lesson was, do you think the size, the width, the magnitude, or the length, the umi or the spoon or the toothpick would make any difference to the rate of heat transfer? What do you think the answer is? The answer is yes. Right? The longer the spoon, the longer the rate of heat transfer. And that's why we have longer spoon for cooking, right? Compare the size of the spoon and because you don't want to cook burn faster. Kaya may spoon sa ego, may ay kung ulo. Okay, mathematically, if you look at all these three questions, there is some maths in it. Okay, for the first one, on the heat transfer, and when you crush the ice into smaller pieces, the rate of melting of the ice is directly proportional to the surface area. See the connection here? You learn mass surface area. Okay, so there is mathematics here in this physics context. For part B, when you have a stronger heat source, the higher the temperature difference, the higher the density difference, and so you can say that the rate of heat transfer in convection is directly proportional to the temperature difference or the density difference in gas or liquid. Right? You know what proportional means from mathematics. Okay? And in part C, in the width of the spoon, is toothpick, you find that the longer the spoon, the slower the rate of heat transfer. So you can say that they are moving opposite to each other. And in mathematical terminology, you can say that the rate of heat transfer is inversely proportional to the size or the width of the length. So you see, there is always a connection to mathematics and why it's important for you to learn mathematics. Okay, that's our warm-up activity. Our main activities is going to be two activities. First activity is metal and heat conduction. Let's have a look at what we're going to do here. Our first activity today is metal. It's called metal heat conduction. Okay, all the materials you need are a metal rod. If you have one with a heat-proof handle like I have over here, that would be perfect. And you need tack. You can even use paper clips or drawing pins. Okay, and you also need wax. You can use Vaseline. For me today, I improvise and I'm using the paper wrap wax and a little plastic fork to smear the metal rod with the wax. Okay, so we are going to put some wax on the metal rod, and then we stick the tack on it, and then heat it up. You use a plastic knife or even in the lab, you smear the metal rod with it, like this, along the length of the metal rod. Why are we doing this? It's because we want to stick the tack on it before we heat it as evenly as possible, and then you take the tack, arrange them about an inch apart from each other, like this. And need a little bit more at the end for our last stack. We put it like this. Okay, and then we are going to light the candles and then put the metal on top of it. If you are going to do this at home, remember you have adult supervision because you don't want to burn your house down. So let's put this along on top of the candle and see what happened. Watch what happened. Right, the metal is in contact with the heat flame, and then you watch what happened. Are the tack going to fall off all at once, or are they going to fall off one by one? You have to be a little bit patient here because we are using a candle. And in school laboratory, you can use Bunsen burner. All right, every school should have a Bunsen burner, which is a stronger heat source, and can make this experiment a bit faster than using a candle. So what's happening? What are you seeing? One is falling off. Okay, one jack is falling off. Remember you're putting the metal rod on the same spot at the end. See? They are falling off one by one. If you keep going, all of them are going to fall off one by one. Okay? Because heat is being conducted from one end to the other. Remember from lesson 1 we were talking about heat conduction, and the heat is being transferred from one atom to the other along the length of the metal rod. Now, the material I say we need a heat-proof glove, but in this case I don't need a heat-proof glove because I'm using a rod with an insulating handle over here. So wala yung mga amiya wala sa heat-proof glove. So this activity, if you keep going, all of these are going to be falling off one by one. All right? See? You can use tack, you can use paper clips, you can use drawing pins, whatever. The idea is to improvise. Alam mo gusto mo lupot ang the experiment later ang fiala. Right? We will ask some questions to enhance what we are learning and what we are seeing later on. Okay, I think we have seen enough of this. Let's turn this off before we burn our house down. So that's our activity number 1. Now remember, after every activity, we should be asking ourselves some questions. Okay, so now that we have done our activity 1, let's have a look at some questions to challenge our critical thinking and also to enforce what we have learned from this activity. First question for us today: did the tack fall off one by one or all at once? What did you see? Of course, you saw that the tack fall off one by one. Not all at once, but one by one. What is this activity demonstrating? Now, you learned from our previous lesson, this is heat conducting, right? Heat is being transferred from one end of the metal rod, going down along the length of the metal rod, and then as the heat gets is transferred, the tack or the drawing beams fall off one by one. What is a heat conductor and what is a heat insulator? From this experience, what is heat conductor and what is heat insulator? Heat conductor is a metal or a rock. It can be any material that conducts heat. Heat insulator is any material that do not conduct heat. Remember the example from lesson 1 of the cooking pot, right? The cooking pot with the metal bowl and the handle is wood. Now, le omea le ulo is of conductor. But the handle, which is a plastic or a wood, that is an insulator. Is metal a conductor or insulator? From this experiment, we should know it is a conductor. It conducts heat. All metals are good conductors. We know that. But do they all conduct heat at the same rate? What do you think? No, they don't. That's right, they don't. Because in real life, silver is the most good conductor. That's the best heat conductor. It's silver. Silver and then copper and then aluminium and stainless steels and so forth, ranking from the best conductor to the lowest. But because silver is expensive and is not readily available, copper is therefore the one highly and mostly used for heat conductor. It is the same reason that copper is used for electrical wiring, because it is a good heat conductor. Right? And it's the same reason why when you see electrical wiring, it always has plastic covering. And it cover the plastic, the copper wire to prevent it getting overheated and also prevent something electrical. Okay, so those are some questions to enhance our knowledge on heat conducting. Our second activity today is going to be heat conduction and heat capacity of water. Only few material we need. As you can see, we only need 2 regular balloons, candle and match, water and funnel. That's all you need. So let's get going. Let's have a look at what this activity is about. Our activity 2 today is called the heat capacity of water. The material we need are just 2 regular lattice balloons. Okay, that's all you need. Some water and a funnel to pour the water into one of the balloons. Okay, so one balloon is without water, the other balloon has water. What are we going to do? We're going to see which balloon pops faster. We will ask the question later on to find out what this activity is all about. Remember, the title of this activity is heat capacity of water. So, I'm going to light the candle. Again, if you are doing this at home, remember you must have adult supervision. Okay? Somebody older with you. Alright, so we have here the balloon without water. See? It's very light. It's just air inside. Now, Do you think when I put this balloon on top of the heat flame, it would pop? Let's find out. Okay, now very important that you have protective gears when you do this, especially for your eyes, in case a piece of the balloon goes into your eyes. Right, so let's find out if it's going to pop. So I'm going to put up some glasses to protect my eyes, and then put the balloon on top of the flame. Right? Stay a bit far away from it. Put it on top of the flame. It pops. Right? That was the balloon with just air. In less than a second, it pops. We will ask the question later and find out why it has popped. Now, light the flame again. And you're now going to put the balloon with water. See the balloon with water? And there's water in it. Elim fanga po dunga pe the balloon yeah. So let's have a look. Make sure you have a tray down here to catch the water in case the balloon pops. Do you think the balloon with water will pop the same time as the balloon without the water? Let's find out. Ang kuha lang kose kongeng ay bad balloon with just air. Now let's have a look at the balloon with water. Do the same thing. Put it on top of the flame. Afay kause konge. Kas, dua, kolu, lima, ongo, fiku, alu, ibas, fulu, sukas. Remember the balloon ilang umakmuang na at pa. Now this one is taking longer. Right? Yes, umi ay le pa balloon nila. Okay? Do you think it will eventually pop? It will. It will, but it's going to take a long time before it pops compared to balloon. It's just air. Right? Now, let's turn off our candle before we answer some questions to find out what was happening. Okay, so we're now done with our activity 2. You heated up the balloon with no water in it, and then you heat up the balloon with water in it. Let's have a look at some questions to enhance what we have learned today. What is heat capacity of water? Do you know what heat capacity of water is? Heat capacity of water is the measure of how much heat water can absorb. Water is a very good heat absorber, and that's why it has a high heat capacity. That's why it takes longer to boil water. If you notice when you boil water, it takes a while before it's boiled. It's because of its high heat capacity. Another real life experience applications of heat capacity of water is when you go to the beach. When you go to the beach in Makafanga, you will notice that the sand would be very hot on a hot sunny day. But when you go for a swim in the water, you will find that the water is still cold. The seawater is still cold despite the hot sunny day. And that's the reason why is because of the high heat capacity of water. The sand conducts heat faster, whereas the water, because of its high capacity, it takes a while before it warms up. Why did the balloon without water pop? from our activity, why did the balloon without the water pop? Why? Because the heat has weakened the balloon, and so therefore the balloon cannot resist the pressure of the air inside the balloon, and therefore it pops. Okay? Why did the balloon with the water did not pop? Or it take a longer time before it did? Okay? What do you think? Why didn't it pop? It did not pop because the water inside the balloon has cooled the balloon up, making the process of heating the balloon a bit longer compared than the balloon without the water. Okay, so this is an application of the heat capacity of water. Was slow down ele vai, ele process ele transfer ele heat, maar ele heat source hanga ele plastic for the latest so le balloon. So the water has cooled the balloon and therefore slow down the process of resisting of the air pressure in the balloon and between the air pressure in the balloon and the heat that has been transferred. Okay, what is a real life application of this physics concept? Do you know? Yes, it is the cooling system of the car. Do you remember that? Well, this is the concept. The application in the heat capacity of water in real life is the cooling system of any vehicle or any car. Because the cooling system is more right? So that's a real life application of this physics concept or the heat capacity of water. All right, so those are our activities. Hope you have learned something useful today. But let's sum up. What have we learned from today's lesson? We have learned today that metals are good heat conductors. Wood and plastics are insulators, right? The application is the cooking pot. And even in the activity that we have done today, I use a metal rod with a plastic handle. The plastic handle prevents me from getting burned. We have learned today that water has a high heat capacity. That's why when you go swimming in the beach, you find the sand hot in a sunny day, but the water is still a bit cold because water has a very high heat capacity. And we have learned today that heat capacity of water is an application in real life is the cooling system of a car engine. Right? So if you are aiming to be a mechanic, you're learning about the heat capacity. All right, so before we end today, remember how I always give you an assignment or a challenge. Okay, so the challenge for us today or an assignment is to investigate further the application of heat transfer in making the Samoan traditional umu. Likaki loy nga malama fa nga umu ka ko Samoa. Pangai ni kau na tau mi meo lau fai lau kamu ai pa fai lau ko vu le fai le lango le o maa. Now your assignment is to go and investigate what are the heat methods involved, what materials are used, how are the materials that you use affect the heat transfer. Okay, think outside the box You can use video clips. You can interview somebody making a move. You can use photos. You can use a combination of all these and then do a presentation. And then when we come back after a week, I want to hear from you about your assignment. Okay? That's a challenge for you. Now, that's our lesson today for physics, heat transfer, the strand one on energy. Until next lesson, so far so good.